So you're standing in front of a press brake for the very first time. You're looking at this machine that's capable of incredible precision and, just immense power. Today, we're going to break down exactly how you set it up, step by step, and turn this complex piece of equipment into your most reliable tool. And yeah, that totally hits the nail on the head, right? You can feel the potential to create something absolutely perfect, but you also feel the weight of what could happen if you get it wrong. Don't worry, that feeling is completely normal. It's actually the first step toward respecting the machine and mastering the process. And that's what this is all about. A perfect bend isn't all about luck. It's about following a process. We're going to walk through that process together, taking you from that initial uh-oh feeling to the confidence that only comes from a systematic, repeatable setup. So why do we obsess over the setup? Honestly, because rushing this part is like trying to build a house on a shaky foundation. Everything, and I mean everything, that comes after is going to be compromised. And just look at this list. These things are all deeply connected. If your angle accuracy is off, you're making scrap parts, which totally kills your production speed. A bad setup puts a ton of stress on your tools and the machine itself, which means they're not going to last as long. And most important of all, a rushed setup is an unsafe setup. It's about making sure the night shift can get the exact same perfect result as the day shift every single time. Okay, before you even think about loading a tool or touching a button, you have to understand what you're working with. Knowing your machine isn't just about theory, it's about building this mental model in your head that lets you spot problems before they turn into disasters. Let's just quickly go over the core anatomy here. You've got the ram, that's the big upper beam that brings all the force down. It's supported by the bed on the bottom. Then there's the backgauge system. That's what positions your part with incredible precision. The tooling, your punches and dies, is what actually shapes the metal. And of course, the CNC controller is the brain of the whole operation, making sure everything happens exactly when it's supposed to. Getting how these parts work together is step one to mastering this thing. And this is why that understanding is so critical. A press brake can exert forces over 100 tons. Think about that. That's enough force to crush a piece of steel like it's a soda can. This isn't a machine you can fight against. It's one you have to work with. And that all starts with respecting its power through safety. Now, these are not suggestions, they are non-negotiable lifelines. Things like light curtains and lasers create invisible safety barriers that'll stop the machine cold. Two-hand controls make sure your hands are clear during the stroke, but you know what the most important safeguard is? It's you. It's always being aware of where your hands are in relation to the tooling. All right, with those fundamentals of safety and machine knowledge locked in, we can get to the heart of it all, the actual setup sequence. This is where all that preparation meets action. Now, this first step, it's so easy to skip, but it is so critical. A clean workspace is a safe workspace, period. That hydraulic warm-up, it's essential because cold oil is thick and sluggish, and that messes with the accuracy of the ram. And finally, making sure the machine is properly homed just means all your measurements are starting from a true 0 point. And here's why that cleanliness is so important. We're talking about a piece of dust, a tiny metal chip, something you can barely even see being enough to throw your entire bend out of whack. So you gotta wipe down every surface, every tool seat, every single time. Now for the tooling. Picking the right die is a huge deal. And a great place to start is this rule of thumb. So let's say you've got a 3mm thick piece of steel. You'd want to look for a die with an opening somewhere between 18 and 24 millimeters. If it's too small, you risk cracking the material. Too large, and you just lose all your accuracy. The machine also really needs to know what it's bending, and this table shows you exactly why. Every material has a different amount of springback after you bend it. Just look at stainless steel. It can spring back up to 6 degrees, but aluminum might only be 1 or 2. So when you tell the CNC what material you're using, you're letting it calculate the perfect amount of overbend so the final part springs back to the exact angle you need. Let's move on to the physical installation. And again, what's step one? Clean everything. Center your die, then install your punch, making sure both are seated perfectly with 0 wiggle room. The goal here is just incredible precision. You're aiming for an alignment within plus or minus 0.03 of a millimeter. It's tiny. And here's a tip that really separates the beginners from the pros. The label on your sheet metal might say it's 3 millimeters thick, but in the real world, it could be 2.95 or 3.05. And guess what?
That tiny little difference is enough to change your bend angle. So always trust your calibers, not the spec sheet.
Ever wondered how you get a perfectly straight bend across a really long part? Well, the answer is crowning. Under all those tons of force, the machine's bed will naturally flex downwards in the middle, kind of like a bow. Without crowning, you get this canoe effect. The crowning system actually pushes up in the center to fight that flex, making sure your 90-degree angle is 90 degrees from one end all the way to the other. So you've prepped the machine, you've selected and installed your tooling, you've dialed in your parameters. Now comes the exciting part. It's time to actually put metal to the test. This is the moment of truth. But we don't just jump right in. First, do a dry run with no material, just to make sure everything moves the way you expect it to. Then, load your material, make sure it's sitting nice and snug against that back gauge. Use the slow speed mode for your very first bend, and watch carefully. Finally, measure it. Check the angle at both ends and right in the middle to make sure your crowning is spot on. So what happens when your first bend isn't perfect? First off, don't panic. This is a totally normal part of the process. This little chart here is your best friend for making adjustments. For instance, if your angle is consistently too open, you just need to increase the y-axis depth a little bit. That's just how far down the ram travels. If the flange length is off, well, you'll want to double-check your back gauge settings. See? Every problem points to a logical solution.
You did it! You made a perfect part, but the job isn't done. The real goal of a professional setup isn't just making one good part, it's making it repeatable for the entire production run and for the next time this job comes up.
This is how you lock in your success. You document everything on a setup sheet. Record the specific tools you used, the actual measured thickness of the material, and any little corrections you made to the bend angle or the crowning. This isn't just for you, it's for the next operator. A good setup sheet means that anyone can walk up and replicate their perfect part tomorrow, next week, or even next year without having to start from square one. And that's the process. From understanding the immense power of the machine to documenting those tiny details that make all the difference, it's a journey from being intimidated to being in control. By following these systematic steps, you've laid the groundwork for safe, accurate, and efficient bending. You now have the foundation for precision. So the only question left is, what will you create?